Now let us consider a case where velocity of particle makes an angle with the magnetic field. Resolving velocity into components, we can say that due to perpendicular component alone, the particle will follow a circular path. Such that the circle lies in a plane perpendicular to the magnetic field. But the particle also has a component of velocity in the direction of magnetic field. We know that a particle moving parallel to the magnetic field does not experience any magnetic force, and thus its motion is not affected. Therefore, resultant motion of particle will be the superposition of the motion due to each component of velocity. Which is a helix. Note that it is a common misconception that the point of start of helical path lies on the center of helix. However, the point of start is at the edge of the helix. Also note that both the components of velocity are perpendicular to the magnetic force, and thus resultant velocity is still perpendicular to the magnetic force. And thus work done by magnetic force is still 0. Now, radius of circular path is the radius of helix, and this distance between two successive cycles is called the pitch of helix. Radius of circular path depends only on the perpendicular component of velocity, and pitch is equal to the distance traveled by the particle along the direction of field in one time period of circular motion. That is, it is equal to this term. Here time period of circular motion does not depend on the velocity of particle. Therefore, pitch of helix depends only on the parallel component of velocity. So for the given velocity and angle, ratio of pitch to radius of a helix will be equal to this term.